This is the continuation of day 1 session. We are going to see the difference between normal relational database queries and data mining queries. By considering some examples, we can distinguish the type of questions that can be solved using normal relational database queries and data mining queries. So let me come to the normal relational database queries. For example, show a list of all items that were sold in the last quarter. We want to know the list of items that were sold in a particular quarter. This can be answered using normal relational database query. Another question is that show the total sales of the last month grouped by branch. And another question, which salesperson had the highest amount of sales? These questions are examples for normal relational database queries, and this can be solved using database queries. And on the other hand, data mining allows searching for trends and data patterns. For example, predict the credit risk of new customers based on their income, age, and previous credit information. Another example is that detect sales deviations by comparing with previous year. Say comparative study with the previous year, and investigate about the sales deviation by checking conditions like any changes in packaging of items or any significant increase in price. These are examples for data mining queries, and this will not be answered using normal relational database queries. Relational databases are one of the most commonly available and rich information repositories, thus treated as the major data source of data mining. Now let's see about data warehouses. Data warehouses are well suited for distributed environment, and we will see how this same all electronics data is stored as a data warehouse. Okay, we can collect the data from different sources. Here we have to collect it from different countries. For example, data source in Chicago, data source in New York, data source in Toronto, data source in Vancouver. We are collecting the data from different sources, or it is collecting from these are collecting from different countries. Okay, we are collecting all these, and we are doing some pre-process including cleaning, integrating, transforming. Then finally we are loading the data into the data warehouse. Sometimes we need to refresh the process, that's why refresh also here. And then we are storing the all electronics data inside a data warehouse. And based on the requirement of customers or clients, we are using some query and analysis tools for extracting knowledge from the stored data warehouse. So this is the kind of data that can be used for data mining. Okay, see, a data warehouse looks like this. Apart from the design of a relational database, a data warehouse is having a multi-dimensional data structure that is called as data cube. So you have to study to draw this cube because this structure has to be included in your answer sheet. So you should be familiar with drawing this cube, and I will explain how it is utilized for representing a data warehouse. Okay, data warehouse will have multiple dimensions. For example, we have to store data in more than one dimension. Here this figure shows a three-dimensional data structure. For the simplicity and for understanding the concept, we are using this three-dimensional cube, but actually a data warehouse can be an n-dimensional, that is more than 2 dimension it will have, but for understanding well, we are dealing with three-dimensional data cube. Okay, so data cube can be of n dimension. Here, for example, we have 3 dimensions. In the lower side, you can see item dimension, and in the left side, you can see 2 dimensions. That is, one side represent time, that is in quarters, and the other side represent address, or in bracket cities. That may not be clear for you. That is address, and in bracket we have cities. Okay, these are the 3 dimensions represented in this particular figure. Okay, and in the bottom side we have different types of items. For example, home entertainment, computer, phone, security. These are items that are selling by this all electronics company, and this all electronics company is having branches in different cities. For example, in Chicago, New York, Toronto, Vancouver. These are the different branches of the all electronics company. And we are storing here the sales data, sales amount, or the quantity of sales happened in a particular time. For example, for quarter 1, for the item home entertainment at the city Vancouver, we have a total sales of 605. Like that, for item computer, in quarter 1 in the same city, that is Vancouver, we have sales 825. And see the upper side, for the home entertainment, for the quarter 1 in the city Chicago, we have a value 440. That is the total sale amount for the item home entertainment in the quarter 1 at the city Chicago. So this is the kind of structure we are storing data inside a data warehouse. So each cell is used to store an aggregate or summary data that can be used for the analysis. So the cell value, for example, here the cell value for home entertainment quarter 1 at the city Vancouver is 605, and for the security item for the quarter 1 at city Vancouver we have 400. That is a cell value. A data warehouse is usually modeled by this kind of structure. And we will see what is a dimension and what is a cell, that I already explained, but we will see again. Dimension corresponds to an attribute or a set of attributes in the schema. Okay, it represents an attribute. Here 3 dimensions. One is address, that is represented as cities, and time, that is represented as quarters, and we have item. And cell stores the value of some aggregate measure such as count or sales amount. Here sales amount is stored in each cell. It may be the count or it may be a sales amount. It is stored as per the requirement. So that is a cell. Okay.